of NumPy. NumPy stands for Numerical Python. It is an open-source library used primarily for mathematical operations in science and engineering applications. NumPy is convenient for performing easy operations on multi-dimensional arrays and matrices. In this lesson, we shall look at some of the essentials of NumPy. With NumPy, we predominantly work with multidimensional arrays. As NumPy is written in C, the speed of executing mathematical operations on arrays using NumPy is high. Apart from the obvious uses of NumPy for scientific and engineering computations, NumPy is also an efficient multi-dimensional container of generic data. As we can define arbitrary data types using NumPy, it aids in integrating with a wide variety of databases. NumPy's array is called ND array. Some of the important attributes of ND array are as follows. NDArray.ndim. The number of axes, dimensions, of the array. NDArray.shape. This is a tuple of integers that gives the size of the array in each dimension. Therefore, for an Mn matrix, shape is nm. The length of the shape tuple is therefore the number of axes, ndim. NDArray.size. The total number of elements of the array. It is equal to the product of the elements of the shape. NDArray.dtype. An object that describes the type of elements in the array. We can use standard Python types for this. In addition, NumPy provides types of its own like numpy.int32, numpy.int16, and numpy.float64. NDArray.itemSize. The size in bytes of each element of the array. If the elements are floats 64, its item size is 64 divided by 8 equals 8. For complex 32, the item size is 32 divided by 8 equals 4. It is denoted by ndarray.dtype.itemSize. NDArray.data. The buffer contains the actual elements of the array. However, for accessing the elements of the array, we usually use indexing and not ndarray.data.